Section 2 of Chapter 2 reviews addition and subtraction of fractions. Add and subtract like fractions. When we say like fractions, we're talking about those fractions that have the same denominator. Fractions with the same denominator are called like fractions. Such fractions have a common denominator. So for example, 3/4 and 5/4. Those are two separate fractions, but they are like fractions because they have the same denominator. Now, when you want to add or subtract like fractions, it's relatively easy. You're going to add or subtract the numerators and place the sum or difference over the common denominator. So to add 3/4 plus 1/4 plus 5/4, or 3/4 plus 1/4 plus 5/4, we're simply going to add 3 plus 1 plus 5. 3 plus 1 plus 5 will give us 9. 9 will be the result, and then the denominator carries over. So the result will be 9/4, 9/4, which is an improper fraction, which then can be converted to a mixed number by using the technique we learned in the previous section, and the result would be 2 1/4. The next objective reviews how to find the least common denominator. The reality is in many cases when we're dealing with fractions, we're going to have fractions that have a different denominator. And that makes it impossible for us to add or subtract those fractions. So what we have to do is find a common denominator between those two fractions. Once we find the common denominator, then we can convert those fractions to the common denominator, and then we can then add or subtract. But before we get to that point, we've got to be able to come up with the lowest or the least common denominator. Okay, just to review, a prime number is a whole number that can be divided without a remainder by exactly two distinct numbers, itself and 1. So the example here of prime numbers are 2, 3, 5, 7, 11, 13, 17. These numbers can only be divided by itself and 1. Okay, so we're going to look at the example here of the process of finding the least common denominator. And the example here we're given is 12, 18, and 20. So what we need to do with 12, 18, and 20 is, and we're going to build up on this. We're going to start at the lower end of the page, and we're going to just add on top of it. So we're building almost like a building on top of the numbers. So whenever you're working on this problem, make sure that you start off and give yourself plenty of space above that number to start moving up. So the numbers are 12, 18, and 20. So let me go ahead and put that on a spreadsheet. Let's put it at the bottom here, 12. So we're going to list 12, 18, and 20 with plenty of room to move up, and you'll be doing this by hand with a pencil and paper. We have 12, 18, and 20, and the first thing we're going to do is figure out whether or not, starting with prime numbers, the lowest prime number is 2. The lowest prime number, well, that's the reason why we reviewed prime numbers at the very top. The lowest prime number is 2. And the question becomes, does 2 go into any of these numbers evenly? And the answer would be, yes, it does. And then the question becomes, well, by how much? So 2 goes into 12 how many times? 6 times. 2 goes into 18 how many times? 9 times. 2 goes into 20 how many times? 10 times. And we're starting to build our tree. And we're going to repeat this. Well, we're going to stay with the prime number 2 because that is the lowest prime number. We're going to go with the lowest prime number and then repeat the question. Does 2 go into 6? And the answer is yes. Well, how many times? 3 times. Does 2 go into 9? Not evenly, so we're simply going to carry up the 9. Does 2 go into 10? Yes, it does. How many times? 5 times. We'll continue our tree up. We're still using 2. Does 2 go into 3? Not evenly, so 9, not evenly. 5, not evenly, so we're going to go to the next prime number. The next prime number is 3. Let's drop 3 here. Does 3 go into 3 evenly? The answer is yes, it does. It's 1. Does 3 go into 9? Yes, it does. How many times? 3 times. Does 3 go into 5? Nope. So we're going to carry up the 5. We'll continue on with the next. We're still, the last number we've used, the prime number, we'll go with 3 again. Does 3 go into 1? No, so the 1 carries up. Does 3 go into 3? It does. How many times? 1 time. And does 3 go into 5? Not evenly, so the 5 comes up. So we have 1, 1, and 5. We can abandon the 3 because we know it doesn't go into any of those. And we'll get to the next prime number. The next prime number is 5. So we'll set 5 here. 5 doesn't go into 1 evenly, so the 1 carries up. 1 carries up. 5 does go into 5 1 time. Now, the objective is that you finally reach a point, just as we've done right now, that all numbers are 1. Once we've got all numbers 1, we are done with our building, our tree, whatever you want to refer to it. And so we're left with these numbers on the left. So we're going to take these numbers on the left and we're going to multiply them. So 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36. 36 times 5 is 180. We can conclude that the lowest common denominator for 12, 18, and 20 is 180. So let's now assume we are trying to add 5 twelfths, 7 eighteenths, and 11 twentieths. We want to add these together. So we want to add those 3 numbers together. But before we can add these 3 numbers together, we have to come up with the lowest common denominator. We've actually done that already. We've actually gone through this tree building process to come up with the lowest common denominator. And we computed that the lowest common denominator is 180. So what we have to do is convert every one of these fractions such that the denominator is equal to 180. So we'll place the denominator to the right of the number, and we'll go through the process of converting these fractions to an equal fraction with a denominator of 180. Now to do this, we're simply going to go, what I used to refer to, or what I was taught, was the backwards Z. So we'll start from the 20. We'll figure out how far can it be divided into 180. Whatever that number is, we'll take that and multiply it by the numerator. In this case, it's 11. And the result will go here. So we have a backwards Z. 20 goes into 180 how many times? 9 times. 9 times 11, 99. So 11 twentieths is equivalent to 99 over 180. We'll continue with the backwards Z. 18. 18 goes into 180 10 times. 10 times 7 will result in 12 goes into 180 15 times. 15 times 5 is 75. So we have found a way to take these fractions and modify them such that they are still equal. These fractions are still equal. All of these fractions equal each other, but their denominator has been converted to the lowest common denominator. In this case, it's 180 for each one of these fractions. At this point in time, since we're adding these together, now we can take the new numbers that we have and add them up. 75 plus 70 plus 99 is 244 over 180. The 180 carries down from the denominator of the previous fractions. From here, we convert the improper fraction to a mixed number, and the result is going to be 1 and 16 over 45. There's some examples, example number 4 that you can work on, but you could just follow the same process. It'll be easier numbers because they're smaller. You can find the lowest common denominator of 4, 2, and 8, and then 10 and 8, and that should get you to solving the problem. That concludes section 2.